This video will identify the divisions of the autonomic nervous system. Remember, this is one of the subdivisions of the peripheral nervous system. All right, so remember, we're here at the level of the nervous system, with the peripheral nervous system being one division of the nervous system, and that peripheral nervous system being further divided into the somatic and the autonomic nervous system, and the peripheral nervous system being further divided into the somatic and the autonomic nervous system. Now remember, the autonomic nervous system is more automatic or involuntary types of functions. And we can further divide the autonomic nervous system into the sympathetic and the parasympathetic nervous system. Now, the sympathetic nervous system mobilizes our body for action. It's our energy output. So think about how you feel if you're driving down the road and you're texting, even though you shouldn't be, and you look up and there's a car stopped in front of you and you slam on your brakes. How do you feel? Maybe your heart's racing a little bit. Maybe your palms get a little bit sweaty. You're breathing a little bit heavier. Maybe the skin on your arms has stood up a little bit. Well, all of that is part of that sympathetic nervous system response, that fight or flight response. It's something that we've inherited from lower animal species. It's the idea that that sympathetic nervous system has detected something stressful, problematic in the environment. And now it's mobilizing our body to either stay and fight or to flee, flight. Now, does your body feel like that forever? No. Over time, it calms down, and that's the parasympathetic nervous system taking back over. It's going to conserve our energy. It's what's happening, functioning during our kind of quiescent state, our baseline levels. And so it kind of just keeps everything on an even keel. So again, the sympathetic nervous system prepares our organs for rigorous activity. It's that fight or flight response, increasing the heart rate, increasing our blood pressure, increasing our respiration. That fight or flight response. It's the same thing you see when an animal encounters its predator, or prey, I suppose. But, when a cat sees a dog, they sit there and they crouch and their hair goes up and they're trying to determine, am I going to have to fight or do I run away? So the sympathetic nervous system, here's just showing you some of the things that the sympathetic nervous system controls: pupil dilation, heartbeat. It's going to inhibit digestion because if you think about it, even if you've eaten a big meal, if you come across something you need to stay and fight or flee, you don't want your food being digested. You don't want energy being wasted there. You want your energy being diverted to increasing your heart rate, stimulating glucose release, stimulating secretion of epinephrine and norepinephrine. So the sympathetic nervous system are comprised of ganglia on the left and right of the spinal cord. So those cell bodies sit very close to the spinal cord. And the sympathetic nervous system uses mostly norepinephrine. As we saw on the last slide, it said epinephrine as well. But so think of the sympathetic nervous system using norepinephrine as the main neurotransmitter. And again, those cell bodies are very close to the spinal cord, so they can have a fast reaction in times of fight or flight need. So that is what this is showing you here. Here's our sympathetic outflow. Here's the spinal cord, and here are the ganglia that are sitting very close to the spinal cord, and this is just showing you all the different organs that they would be affecting. So here's the ganglia, and norepinephrine is that main neurotransmitter that the sympathetic nervous system uses. Now the parasympathetic nervous system, remember, is going to kind of be our baseline. It facilitates kind of vegetative, non-emergent responses. It decreases the functions that are increased by the sympathetic nervous system, dominant during our relaxed states, our kind of quiescent states. So here's just showing you some of the functions of the parasympathetic nervous system. It's going to contract people. So it kind of does the opposite of what the sympathetic nervous system does. It's going to slow the heartbeat. Again, the opposite of what the sympathetic nervous system does. And it's going to stimulate digestive activity. So when we're kind of in a relaxed state and there's nothing stressful or harmful going on, that's when our food gets easily digested. Now, the parasympathetic nervous system, because it doesn't need to have an immediate response, it has what we call long preganglionic axons and short postganglionic fibers. Now, I'm going to show you those on the next slide, but I also have another video that you can watch that demonstrates this idea very well. So these postganglionic axons of the parasympathetic nervous system release mostly acetylcholine as their neurotransmitter. So here you can see that the cell bodies are out much closer to the organs that they're going to affect. So you have these long preganglionic fibers, so going out to the cell bodies, they're very long, but very short postganglionic fibers that again release acetylcholine. And I had a student last semester give me this acronym that maybe will help you to remember the neurotransmitters. She came up with the acronym SNAP for sympathetic norepinephrine, acetylcholine, parasympathetic nervous system. So that's how and I thought that was a pretty cool acronym, so I thought I would share that with you. Again, if you ever have any that you come up with, please feel free to share them with me, because if I think they're useful, I will pass them along. So SNAP, sympathetic norepinephrine, acetylcholine paired with parasympathetic.